Hi, my name is Saeed Ali Akbarzadeh. This is a fourth part of the secondary designing of the medium voltage panels. In this video, I'm going to briefly explain you about one of the protection relays and test block and test block. If you like this kind of video, please subscribe it and hit the bell in order to inform you for the next videos. So follow me please to see the electrical diagram. Okay, the name of this page is G5 and the next one is M41. This page is related to the DC power supply of the protection relays here, and the circuit is a protection, positive and negative of the protection circuit. It comes from G1 page and goes to the M43. Okay, in this circuit, positive first comes to the test block X100 and its type is MMLG01, comes to the 13, and from the 14 go to the DC power supply of the protection relays. Terminal is positive terminal is 33. The name of protection relay is F101 and its type is P122. And the negative polarity first comes to the 16 of the test block and from the 15 goes to the 34 terminal of the protection relay. Let me show you these two devices, protection relays and test block in the picture. This is the protection relay. Its type is P127 and this is a test block or test switch. The usage of test block is just for testing of the protection relays by the commissioner, nothing more. And current, voltage, binary inputs and DC power supply first come to the test block and then they go to the protection relay, and binary outputs from the protection relay go to the test block, and from the test block go to the other part of the circuit. Okay, let me add something else. It's not necessary for all binary outputs and binary inputs to be transmitted from the test block, because commissioner needs just some of them, not all of them, for the testing of the protection relay. Let me add something else again. Some designers believe that they have to use a test block in the path of the DC power supply of the protection relays, in the positive side and the negative side. And the reason is, before going to the test of the relay, DC power supply must be off by removing of the cover of the test block, and then the commissioner can insert the test handle into the test block in order to test the protection relay. And some other designers believe that they don't need to use test block in the path of the DC power supply of the protection relay. And the reason is, before going to the test of the relay, all the time circuit breaker is open and everything is okay for the testing of the relay. But if the panel is energized, commissioner must know that he must open the trip wire from the trip circuit, and then he can insert the test handle into the test block. There is another figure of the protection relay. Its manufacturer is Areva, and here you can see the electrical diagram of the protection relay. Its type is P122, which is extracted from the manual. Here you can see the DC power supply of this protection relay, and these channels are related to the current channel, channel A, B, C and neutral, for 1 amp of the CT secondary, and they could be again for the 5 amp of the CT secondary. And also there are some binary inputs and binary outputs here, and communication port for 485 for the network connection. Let me zoom in to show the power supply of this relay. 33 and 34 is the terminal for the DC power supply. Alright, in this document which is extracted from MMLG01 manual, I'm going to show you protection scheme or protection relay and test block and CT connection all together. Here we can see protection relay or protection scheme and test block. Here all terminals, even terminals are related to the protection relays, and odd terminals are related to the other part of the schematic diagram. Okay, let me explain them more for you. We have CT, the path of current flow from the CT to the terminals of the test block 21, 23, 25, and 27, and even terminals go to the current channel of the protection CT here. And for the DC power supply, positive and negative of the DC is connected to the 13 and 15, and from the 14 and 16 go to the protection relay. There is a space between 13 and 14 terminal which is filled or connected by a special pin, and this pin is located on the back of the cover of the test block. Let me show you in the picture. This is the cover of the test block. In the middle and back of the cover of the test block there is a pin. This pin make a connection between 13 and 14 terminals, and if we remove this cover we lose the power of the protection relay. There is another type of the test block. It doesn't have this pin. All the connection of the test block are the same. And also there are some binary outputs, alarm and trips. First they go to the test block, and from the test block they go to the other part of the schematic diagram. For example, trip signals go to the circuit breaker in order to open the CB, and alarm goes to the alarm annunciator or other part of the schematic diagram. And from these even terminals of the test block, commissioner can test the protection relay, for example, injection of the current from these terminals by the test device from these terminals into the current channel of the protection relay. And also he can make a connection between 13 and 14 and 15 and 16. Like this, he can provide the DC power supply for the protection relay. Then after increasing of the current from these terminals of the test block to the protection relays, some of the binary outputs is going to operate, and through these terminals of the test block, binary outputs will go to the test device. And then test device can record the time of the operation of the binary outputs. Alright, let me show you the figure of the test handle and test block. Orange figure is the test handle. It is inserted to the test block and it's ready for the commissioner to test the relay. Now commissioner can make a connection between test device and orange figure, I mean test plug, and then he can increase the current and see the result of the protection function and time of the binary outputs. Different manufacturers have different type of the test block and test plug. For example, this product belongs to the ABB. This is the test block and this is the test plug of the ABB. And for the Siemens company, this is the test switch of the Siemens company. There are different type of the test switch, and test handle is going to connect it to this part of the test switch. Okay, there is another type of the test block. Its manufacturer is Antrolec. Some designers use this device in the path of the current of the flow to the protection relays, and there is another type of it for the voltage. And some designers don't use them for the protection relays. They just use them for the measuring devices, such as measuring centers and ammeters and voltmeters. Alright, let's continue our schematic diagram. This page is page 41, and DC polarity is plus and minus of C. This is for control and close and interlock circuit. It comes from G1 page and come to here and goes to the M42, sorry. First line belongs to the local remote position. This is the selector switch. It has two positions and the label is S110. If it is in the local position, this auxiliary relay will be energized, and if we change it to the remote position, this relay will be de-energized. Let me show you in the front panel. This is the selector switch of the local remote position. Some designers write here maintenance and remote, not local remote, because they think if you want to do the maintenance for the circuit breaker, you have to move the circuit breaker in the test position and do the maintenance on it. That's why we have to select on the maintenance position. If some people ask me why we need to use this kind of selector or switch in our panel, I need to answer them. Operators need two alternatives for their operation. First, if they want to do the operation in front of the panel, they have to select the selector switch on the local position or maintenance position and do their job. For example, close command, open command, and lockout reset and read the value of the current and voltage or something like this. And the second one, if operators are in the other side, I mean the control room or upstream system, they can send the command by the network communication to the protection relays, and then binary output of the protection relays can send the command to the circuit breaker. That's why they need to change it to the remote position. In this case, system integration is needed. Next line or next circuit is for enabling of the earth switch. There is a push button here. Let me show you in the picture. This is the black push button for enabling of the earth switch. First we have to push this push button, and then circuit breaker must be in the test position, and there is a coil in the earth mechanism. After pushing this push button, this coil will be energized. Then in this situation, operator move the handle and put it in the earth mechanism and turn it into the clockwise 90 degree soft, and next 90 degree he must push it a little bit more until close or open the earth switch. I've shown it in the previous video. And next circuit is interlock conditions. We have three conditions for the energizing of this auxiliary relay. Let me zoom in to show its detail. First, there is a auxiliary relay which is related to the open position of the earth switch. There is normally open contact of this relay. This relay is K140, and the label its coil is in the page of M45. Let me show you the coil. Page M45, first line. Yes, first line is earth switch open position. This is the control circuit. If the earth switch is open, this coil will be energized, K140, and after energizing of this coil, its contact will be closed. Next condition is a lockout reset, F481 in the page of N6. It must be reset. Let's go to the page N6. Okay, and this is the lockout relay. Lockout relay F481. This circuit is for locking of the relay, and this circuit is for resetting of this lockout relay. How would it be operate? By operating of the binary output of the protection relay through this path. Test block will be locked. In this situation, we cannot close the circuit breaker unless we push this push button in order to reset the lockout. And then one of the conditions for the closing of the circuit breaker will be okay. As you can see, this lockout relay has some normally open contacts, which one of them is in this circuit. After energizing or locking of this relay by this path, this contact will be closed, and this signal lamp will be light on, which is connected to this push button. Okay, let me show it in the picture. Yes, red push button is for resetting of the lockout. There is a light in it. After energizing of the lockout, it will be on. Let me show you the figure of the lockout relay. This is the rail mounted of this relay. This relay will be locked after operation of the protection of the relay or some other trip signals, and then in this situation we cannot close the circuit breaker. Why? Because we usually use the normally contact of this relay in the path of the interlock condition or the path of the closed circuit, and after operation of this lockout, the path of the closed circuit will be open unless we push the red push button for resetting of the lockout relay, and then one of the conditions which is related to the lockout will be okay, and then we can close the circuit breaker. Alright, next condition is TCS not operate. If this condition is okay, then this auxiliary relay will be energized, and then most part of the interlock conditions for closing of the circuit breaker will be okay. For TCS, there are two meanings. First, trip coil supervision. This is for just checking of the trip coil, and second, trip circuit supervision for checking of the trip coil and circuit of the trip. Let me assure you, the complete design is a trip circuit supervision, not trip coil supervision. I saw some drawing or schematic diagram which TCS is ordered or it is capable for the trip circuit supervision, but unfortunately designer designs the circuit for checking just the trip coil, nothing more. And this matter is a comprehensive issue, and let me explain you and expand it in the next videos, and I will show you the differences between trip coil supervision and trip circuit supervision in different circuits. Let me add briefly something else. In the circuit breaker, we usually have two coils in the level of the medium voltage. One of them is closed coil, another one is trip coil. The importance of the trip coil is much more in comparison with the closed coil. Why? Because when the circuit breaker is closed, the path of the trip circuit and trip coil must be completely healthy and ready for the operation of the protection relay in order to trip the circuit breaker. So it was the fourth part of the secondary designing of the medium voltage panels, and I know that the way is not so fast, but I try to explain you with all the details of the equipment and electrical diagram. And I guess you are waiting for the training of the some kind of softwares which is related to the configuration of the protection relays, such as Siemens, ABB, Schneider, and Areva. I promise you, if I have enough time, I will provide the videos for them. I would appreciate you if you put your comment on the below, and don't forget click on the appropriate buttons like and subscribe and hit the bell, please. Bye.